this is SP Gubbi online classes for NCERT and Cbse 10th standard for mathematics and science. So in the previous session of quadratic equations for 10th standard, we had solved very important application problems on quadratic equations, which involves the factorization method of solving quadratic equations. I hope you have completed the remaining solution of the problem. So most of you are sending the solved problems to me through the WhatsApp. It's a fantastic work. Just keep it up, the good work. So here in today's session we will be going with the equations which are reducible to the quadratic equations. So these are also very important. They may be asked in your examination for 2 marks. Very important. So it's a part of the problems what we had done in the application problems. It was better if I would have done it earlier. Okay, it's okay, no problem. So here there are certain criteria to be followed while solving these type of problems. I have picked up very unique problems from various sources. So we will be going with the problems today. So if upon solving these equations reducible to the quadratic equations, if you are not able to solve the quadratic equation by the method of factorization, leave a gap there. When I complete the formula method of solving quadratic equations, then come back to this particular part and apply the formula and find out the roots. No problem in that. So in this particular problems, I will be leading you until I get the quadratic equation in the form of ax square plus bx plus c is equal to 0. So after that, please carry with the problem. Right. So in today's session, we are having the first problem here. Solve for x. 1 by x minus 2 plus 2 by x minus 1 is equal to 6 by x. So you have to solve for x. In the sense, solve for x means you have to find the value of x. In other sense, you have to find the roots of the quadratic equation when you solve this particular equation. Right? All is the same thing. So let us take the LHS. So 1 by x minus 2 plus 2 by x minus 1 is equal to 6 by x. So in the LHS we will prefer this because there are 2 fractions here. So we will take this and take LCM for the denominators, right? So for x minus 1 and x minus 2, LCM will be x minus 1 into x minus 2. So first fraction 1 by x minus 2 into this. So x minus 2 cancels. Remaining is x minus 1 into 1. That is x minus 1 plus 2 by x minus 1 into this. X minus 1 cancels. 2 into x minus 2 is equal to 6 by x. So this is taking LCM. So you have to be very careful here. If it is plus, okay, no problem. But if it is, you are having minus here at this point, you have to be still more careful because there is a chance of some silly mistakes or simple errors done by the student. Right? Okay. So x minus 1 is here. Plus 2 into x is 2x. 2 into plus 2 into minus 2 is minus 4 by x into x square. X into minus 2 is
minus 2x.
Okay, minus 1 into x minus 1x. Minus 1 into minus 2 is plus 2 is equal to 6 by x. So before multiplying the numbers, you have to first multiply their signs and then you have to multiply the numbers. Got it? Okay. So simplify the algebraic terms, that is 1x plus 2x. It is 3x minus 1 minus 4 is minus 5 by x square. No like algebraic term to simplify. So minus 2x minus 1x minus 3x plus 2 is equal to 6 by x. So what is the next better step to be done?
Cross multiply.
Yes, exactly. So you have to go with the cross multiplication. So x into, let us do this first, x square minus 3x plus 2 into 6. 6 into x square minus 3x plus 2 is equal to x into 3x minus 5. X into 3x minus 5. Okay. 6 into x square is
6x square.
6 into minus 3x
Minus 18x.
6 into plus 2 is
Plus 12.
is equal to x into 3x
3x square.
x into minus 5.
Minus 5x.
Very good. Nice. Good answer. So, we will transpose this term to the LHS, we will transpose this term to LHS and make RHS equal to 0 so that we will set up an equation here. Okay, right? So 6x square minus 3x square, it is minus 18x plus 5x plus 5x plus 12 is equal to 0. Right. So 3x square minus 6x square minus 3x square is
3x square.
okay. So 3x square minus 18x plus 5x minus 13x plus 12 is equal to 0. So exactly we have reached the quadratic equation. If possible, solve this quadratic equation by the method of factorization. If it is not possible, because all quadratic equations cannot be solved by the method of factorization, right? So therefore, if it is possible, solve it or leave it a blank here. So when I derive the formula to solve quadratic equations by using the formula method, then come back to here and complete the problem, right? Okay, it is for 2 marks. Okay, now let us get into the second problem. On the same line, solve for x. 2x by x minus 5 whole square plus 5 into 2x by x minus 5 minus 24 is equal to 0. So most of the students, what they do here, they try to square this. That is 2x whole square is 4x square, x minus 5 whole square is, they are going to expand it, they will make it a very big complicated problem by themselves, right? So that is not the preferable method here. So I will tell you a very simple method for solving this, right? It's a very unique problem. So 2x by x minus 5 whole square plus 5 into 2x by x minus 5 minus 24 is equal to 0. It's very simple. So your observation plays a very important role here. You have to observe it. So here inside the bracket we have 2x by x minus 5, and also here inside the bracket we have 2x by x minus 5. The particular term repeats itself at 2 places in the form of a fraction. So instead of writing 2x by x minus 5 while solving the problem in all the particular steps, we will represent that 2x by x minus 5 by a variable, simple variable, right? So let 2x by x minus 5 is equal to y. Guess it as y. When we get the roots, we will reconvert that. No problem. When we get the roots, when we reach to the roots, we will reconvert into the original product, right? So instead of 2x by x minus 5, now you are eligible to substitute y. So that becomes y. For this I have substituted y, it has square. So it is y square plus 5 into this entire thing is y minus 24 is equal to 0. So y whole square is y square plus 5 into y is 5y minus 24 is equal to 0. So let us solve this by the method of factorization. So you know sum product method, y square into minus 24 is minus 24 y square. So you have to search for 2 numbers in such a way that the sum of those 2 numbers should give you plus 5y and the product should give you minus 24 y square. Okay? Yeah, come on. 8 3s are 8 into 3. Yeah, exactly. So 8y and 3y. So to get plus 5y as the answer, you have to put plus sign for 8y and minus sign for 3y. And plus into minus is minus, 8 3s are 24, y into y is y square. I hope you are getting it, right? So instead of this plus 5y, let us substitute these 2 values. So y square plus 8y minus 3y minus 24 is equal to 0. So out of 3 terms, you have got 4 terms here. So take a combination of 2 and 2 terms, right? Let us take common in this. So in the first 2 terms, we have y as common. So this can be written as y plus 8. Y into y is y square, y into 8 is 8y. So these 2 terms both have minus sign, and also the multiple of 3 is 24 is present. So let us take minus 3 as common. So that becomes y plus 8. So minus 3 into y is minus 3y. Minus into plus is minus 3, 8s are 24. Okay. So now, out of 4 terms we have 1 and 2 terms. So out of these two terms we have to take again common. So we can take y plus 8 as common here. So into remaining thing is y in this term, and in this term we are left over with minus 3. So that becomes y minus 3 is equal to 0. Now this into this is equal to 0 means m into n is equal to 0. If m into n is equal to 0, then either m will be equal to 0 or n will be equal to 0. So therefore y plus 8 is equal to 0 or y minus 3 is equal to 0. So y is equal to minus 8 or y is equal to 3. Okay. So this is not the solution. This is not the solution actually. Right? Because we have considered 2x by x minus 5 is equal to y, and we have got the value of y here. So either of both of any one you can take. So better go for positive value. So but 2x by x minus 5 is equal to y. Y value is 3. So 2x by x minus 5 is equal to 3 by 1. So 3 into x minus 5. X minus 5 is equal to 2x. 3 into x is 3x minus 15 is equal to 2x. So 2x gets transposed to LHS. So it becomes 3x minus 2x is equal to minus 15 to the RHS. Okay. 3x minus 2x is x is equal to 15. So the one of the root what we have got is 15. So if you want another root, we can find it out easily by substituting minus 8. So 2x by x minus 5 is equal to minus 8 by 1. So 2x into 1 is 2x. Minus 8 into x is minus 8x. Minus 8 into minus 5 is plus 40. Very good. So minus 8x goes to the that is LHS. So 2x plus 8x is equal to 40. Let us take 2 as 2x plus 8x is 10x is equal to 40. So x is equal to 40 by 10. 10 ones are 10 fours are. So x is equal to 4. So which are the two roots?
15 and 4.
Yes, the two roots of that particular equation is x is equal to 15 and x is equal to 4. So this is a very unique problem. So if you are getting such type of some complicated problems like this, so instead of 2x by x minus 5, substitute a value there, substitute a variable there, solve it. When you get the values, resubstitute the values to the guessed, the assumed thing, then you will get the real roots. Right? Okay. Okay, let us get into the third problem. The similar type, solve for x. Solve for x. Okay. So it's not a big complicated something like a lost problem. It's not like that. We will go with the normal procedure here. So 3 by x plus 1 plus 4 by x minus 1 is equal to 29 by 4x minus 1. So now in the LHS, let us take the LCM for both the fractions. So LCM is x plus 1 and x minus 1. So x plus 1 into x minus 1. So 3 by x plus 1 into this, x plus 1 cancels. So 3 into
X
minus 1 plus here 4 by x minus 1 into this, x minus 1 cancels. So 4 into x plus 1 is equal to 29 by 4x minus 1. Okay, we will simplify this and also this. So 3 into x, 3x, 3 into minus 1,
minus 3
plus 4 into x,
4x
4x plus 4 into plus 1,
plus 4
plus 4 by. Okay, so I hope you are guessing something here. Can you identify the identity which can be applied here? Yes. So it is a plus b into
A minus b,
which can be written as x square minus 1 square. So 1 square is 1. Okay, so 29 by 4x minus 1. Okay, let us simplify this. So 3x plus 4x is 7x minus 3 plus 4 is plus 1 by x square minus 1 is equal to 29 by 4x minus 1. So better now the most possible step is cross multiplication. So x square minus 1 into 29. 29 into x square minus 1 is equal to 7x plus 1 into 4x minus 1. That is 7x plus 1 into 4x minus 1. Okay. So 29 into x square is
29
x
x square.
square. 29 into minus 1 is
Minus 29
is equal to 7x into 4x.
28
28x square. 7x into minus 1
minus 7x
plus 1 into 4x
plus
4x. Okay, plus 1 into minus 1.
minus 1
Right. So we'll transpose this, or we'll simplify this first. So 29x square minus 29 is equal to 28x square minus 7x plus 4x is
minus 3x
minus 3x minus 1. So we'll transpose all the terms here into the LHS and make RHS equal to 0. So 29x square plus 28x square after transposing it is
minus 28x square
minus 3x after transposing
plus
plus 3x minus 29 minus 1 after transposing is plus 1, which is equal to 0. Okay. So plus plus 1 is equal to 0. So 29x square minus 28x square is x square plus 3x. Okay, that's a single term. Minus 29 plus 1
minus 28
is equal to 0. So this is the required quadratic equation in the form of ax square plus bx plus c is equal to 0. Solve this by the method of factorization to get the values of, that is to the 2 roots of x. Right. Okay, let us get into the fourth problem. So it's similar type. Solve for x. 1 by a plus b plus x is equal to 1 by a plus 1 by b plus 1 by x, where a plus b is not equal to 0. So if a plus b becomes equal to 0, then it remains 1 by x. 1 by x and 1 by x maybe gets cancelled. So you will be left over with 1 by a and 1 by b. So therefore he has put up a condition, that is a plus b is not equal to 0. That's all right. So let us take the problem. So 1 by a plus b plus x is equal to 1 by a plus 1 by b plus 1 by x. So now transpose this 1 by x to the LHS, right? So it becomes 1 by a plus b plus x minus 1 by x is equal to 1 by a plus 1 by b. Is that clear?
Yes, sir.
Okay. Now take the LCM for a plus b plus x and x. So the LCM will be x into a plus b plus x, right? So 1 by a plus b plus x into this gives a plus b plus x, a plus b plus x cancels, remaining is x. What is the sign here?
Minus.
You have to be very careful here, right? So whatever comes in the next step, you have to keep it inside brackets, right? So this minus sign is like a terrorist. You have to be very careful, right? In front of a terrorist, we should wear bulletproof jackets. So those jackets are nothing but the brackets, right? Nice. So minus 1 by x into this. Here x and x is going to get cancelled. So 1 into this remains. So that is a plus b plus x is equal to 1 by a plus
1 by b.
1 by b. Okay. So x minus into plus a is minus a, minus into plus b is minus b, minus into plus x is minus x by x into a plus b plus x is equal to 1 by a plus 1 by b. Okay, now so here plus x minus x is going to get cancelled, so you are left with minus a minus b. So it is minus a minus b by x into a plus b plus x. X into a plus b plus x is equal to, so you have to take LCM on RHS also. So for a and b, LCM is ab. So 1 by a into ab is b plus 1 by b into ab is a. Okay. So now in the numerator, let us take minus 1 as common, because a also has negative sign, b also has negative sign. So minus 1 if you take it as common, so you are left with a plus b by x into a plus b plus x is equal to, b plus a can be written as a plus b, because commutative property for addition holds good. right? So by AB. So now, as these two fractions are separated by equal signs, so we can cancel this a plus b and a plus b by using the axiom. If equals are taken away from equals, the remainders also remain equals. Right? So on that axiom, right? So minus 1 by x into a plus b plus x is equal to 1 by AB. So we can go with the cross multiplication better. So x into a plus b plus x into 1 is x into a plus b plus x is equal to minus 1 into AB is minus AB. Right? Is it x into a is ax plus x into b, sorry, x into b is plus x into x is equal to minus AB. So we will transpose that minus AB to LHS. So that becomes ax plus AB minus AB transposing plus AB plus bx, right, plus x square will write here. So x square plus ax plus AB plus bx is equal to 0. I hope you can guess for these two terms. Can you take common there for those two terms? Yes, you can take x into x plus a plus here b into a plus x is equal to 0. So x plus a plus x are one and the same. So here in these two terms we can take x plus a as common. So remaining is x plus b is equal to 0. So this into this is equal to 0 means either this should be equal to 0 or this should be equal to 0. So therefore x plus a is equal to 0 or x plus b is equal to 0. So x is equal to minus a or x is equal to
minus b.
Right. These are the two beautiful roots. Right. So it will be for 3 marks in your examination. So it has been asked in previous 3 final examinations of Cbse and also some foreign exams. Right. I hope you enjoyed this. Okay. So now we will be going with a very important derivation of quadratic formula, which is very important, and based on this a 2-mark question will be compulsory asked in your examination, right, as it also comes in what we call the passing package. So usually in the passing packages in the recent years, in the previous many years we didn't used to do all these passing packages or nothing like that. So these 3 from last 3 years we teachers are seeing that passing package. It seems very, the students are not studying well, so at the nth moment to make the students to pass in the examination, so the teachers have designed this passing package, right, the minimum dosage required to pass a student in the examination, right. So in that it is going to come for 2 marks, right. So here earlier I had discussed regarding the quadratic equations. So in the method of solving quadratic equations, there are 4 methods among them. One is the factorization method. Until now you have enjoyed it, right, that is sum and product method. Second one is the formula method. By using formula we can find out the roots of any given quadratic equation. And third method is the method of completing the square, or in other words it is the SRIDHARAS method. The great Indian mathematician, he designed that method of solving quadratic equations by the method of completing the square. And the fourth method is the graphical method. So according to the news what I have got until now, the government has taken out the SRIDHARAS method of solving quadratic equations, and the graphical method is not in your textbooks. So therefore we are left with only 2 methods of solving any given quadratic equation. So among them, one we have successfully completed, that is the factorization method, and the remaining one is the formula method. So here the question arises, why, sir, why already we have a formula method, that is the factorization method to solve quadratic equations, but so why another method of solving quadratic equations here? So the criteria is, out of 100 quadratic equations, if I take 100 quadratic equations, among them 3 to 4 quadratic equations can be, the roots of those quadratic equations can be found out by the method of factorization, and the remaining 96 to 97 quadratic equations cannot, the roots of those quadratic equations cannot be found out by the method of factorization. So in many day-to-day life situations we need the roots of the quadratic equation, right? So therefore we are going with a universal method of solving quadratic equations, that is finding out the roots of a given quadratic equation, right? Compulsory, whether it is any type of quadratic equations, let A, B and C real numbers, let the real number have any values, don't worry about that. Using this formula method you can compulsory find out the roots of any given quadratic equation. Therefore this formula method is known as the universal method of solving quadratic equations, right? So here the derivation for the quadratic formula is not in your syllabus, that is, it will not be asked in the examination for any marks, it is just for your pure knowledge. Just I cannot say this is the formula, take it, start using it. See, that should not be, because if somebody asks you how did you get this formula, you should be able to convince them. So this is how we reach to the formula. So this is knowledge, pure knowledge I am doing this. So here one speciality of this particular method is we are deriving the quadratic formula, that is for the method of solving quadratic equations, what the formula we are deriving now, the procedure what we are going to follow here is the method of completing the square or the SRIDHARAS method. So here you are going to taste the method of completing the square. Here you are going to come to know about it, right? So let us get into the derivation. Listen very carefully, observe. So some logical things are hidden inside the derivation. So while deriving, I will come out of the steps. I will try to convince you certain things. Listen to that. Observe very carefully. By heart, please remember the formula and try to apply. Right? If you are very interested in derivation also, okay, practice it. Right. So here, standard form of quadratic equation we will take. Standard form of quadratic equation is, that is ax square plus bx plus c is equal to 0. So this is a quadratic equation, that is, we say that it is a standard form of a quadratic equation where a, b and c are real numbers. Compulsory a, b and c are real numbers, where a is not equal to 0, right? A, b, c and they are called constants also, where c is a real constant, right? And x is called as the variable. And all the terms in the quadratic equation should be arranged in the decreasing order of the powers of the variables, and the equation should be equated to 0. So if all these characteristics apply for a quadratic equation, then we say that the quadratic equation is in its standard form, right? So this is the standard form of a quadratic equation, right? So in the first step of deriving the formula based on, that is the SRIDHARAS method, we are going to make the coefficient of x square equal to 1. That is, the coefficient of x square should be equal to 1. So here the coefficient of x square is a. So in the first step of derivation, I have to remove this a outside. I have to remove this a, so that if no real number is present as the coefficient of x square, so we assume that there is 1. So the first step of derivation is remove a. So the coefficient of x square in this quadratic equation should be compulsory 1. Okay. So let us get into the proof. So ax square plus bx plus c is equal to 0. So I want to remove a, so just I will wipe it out. A is gone. So I cannot do that. So it has to be done mathematically. So divide by a on both sides. Divide by a on both sides. As it is an equation, whatever you do it in the LHS, the same thing should be done in the RHS to balance the value of the equation. Right. So ax square by a plus bx by a plus c by a is equal to 0 by a. I am dividing the entire equation by a. Okay. So A and A cancel, so you are left with
X square.
x square plus bx by A plus c by A is equal to 0 by anything is
0.
it remains the same, right? So this is the first step. So this entire thing what I have written here is the first step in the process of derivation. So what is to be done in the next step? So in the next step, you have to transpose the real constant with its sign to the RHS. Transpose the real constant to the RHS, right? So x square plus bx by A is equal to plus c by A. When it gets transposed to the RHS, it is going to become minus
C by A.
c by A. So from here, the real story starts, right? So these are all the initial steps to be followed. From here, the real story starts. That is the SRIDHARAS method we are going to apply, right? Now, look at the LHS. We have x square plus bx by A, and in the RHS we have minus c by A. So don't worry about the RHS now, it will be there. Look at the LHS. I have to, the target for me, the task for me here is to make this LHS a perfect square. Make this LHS a perfect square. Perfect square will be of two types, a plus b whole square or a minus b whole square, right? So now, x square plus bx by A, nothing is there apart from this. So now, I have to make this as a perfect square. A perfect square will be in the form of a plus b whole square, or it will be in the form of a minus b whole square, right? So this is not possible. A minus b whole square is not possible because between these two terms we have plus sign. So therefore you have to convert this into a perfect square, which is in the form of a plus b whole square. Okay, right? So a plus b whole square can be written as a plus b whole square can be written as a square plus 2ab plus b square. So in the place of a square we have x square. In the place of a square we have x square. And in the place of b square we have bx by A. No, it's not possible because it is a perfect square here. Here it is not a perfect square. So plus bx by A, then it represents plus 2ab. Right? So then we have to search for this b square. We have to search for b square. We have to put a b square here so that it becomes a perfect square, so that we can proceed further. Right? So we have to derive the value of b here. Right? So as we have to put b square here, I cannot directly put b square there. Just first I have to find out b value, then square it, put it there. Right? So using these two, comparing with these two, we will derive the value of b. Right? So what is x square? It is a square. So a square is equal to x square. When you take square root on both sides, right, it is going to become a is equal to x. So one value we have got, a is equal to x. Then, now this 2ab is nothing but bx by A. So this is very important. 2ab is equal to bx by A. This is in the form, right? Now 2ab here is 2 is a constant. What is A equal to? X. We have to find out b, right? So here do we have x? Yes, we have x. That is, I am going to write this value now. A is equal to x. I am going to write this into, instead of A I have written x. I will write 2 here because it should be in the form of 2ab. 2 into x into, I should get b value. I want b value such that when you simplify this, you should get bx by A. Should get bx by A. I hope you are getting this. So 2ab is bx by A. So I am writing 2ab is equal to 2 into, the same 2 continues, into, instead of A it is x, I have to write b here. So that when I multiply all these three, you should get back bx by A. So I have to search for b. So that b can be b by 2a. Is this possible? b by 2a. So here 2 and 2 gets cancelled. you are left with b into x, bx by a.
A.
So instead of this 2ab, instead of b I have got b by 2a, right? So if I substitute b by 2a whole square here, then it will be equal to a perfect square, because it is in the form of a square plus 2ab plus b square. This is a perfect square, right? We will add b by 2a whole square on both sides. Just we cannot add it for one side, we will add it for both the sides to balance the equation. I hope you got this. You understood this? How you get b by 2a? How you get, and why b by 2a whole square should be added? Right? I hope you got the concept. Right? So I will take out this. Okay. So what should be added to LHS and RHS to make it a perfect square?
B by B.
So add b by 2a whole square on both sides. Add b by 2a whole square on both sides. How you get b by 2a whole square? That was the story there. Right? Okay. So x square plus bx by a plus b by 2a whole square is equal to minus c by a plus b by 2a whole square. I have added b by 2a whole square on both sides. So equation is balanced. Okay, now this is in the form of a square plus 2ab plus b square. So this should be written as a plus b whole square. I have given you a square plus 2ab plus b square. Write the short form of that, that is equal to a plus b whole square. So here I have a square plus 2ab plus b square, which should be written as a plus b whole square. So easily you can write it. So in place of a square, I will just compare this. So a square plus 2ab plus b square, it is in this form. You have to write this in a plus b whole square. So a square is x square, then a is x, that is x plus b by 2a whole square is b square. Then what is b?
B by 2a.
b by 2a. Take square root on both sides. Okay. So x plus b by 2a whole square is equal to, now we will apply this square for both the numerator and the denominator. So that is minus c by a plus b square by 4a square. B square by 4a square. Okay. Now x plus b by 2a whole square is equal to, let us take LCM for the denominators. So it becomes 4a square minus c by a into 4a square is minus 4ac. I hope you got this. LCM for a and 4a square is 4a square. Yeah, if you have doubts you can take it. Factors of a are 1 and a. Factors of 4a square are 2 into 2 into a into a. Right? So common thing is a and a. We don't have any other common things. So multiply the things. 4, 2 2s are 4. 4 into a, 4a, and 1 time common you have to multiply, that is 4a square. It's not 4a cube, right? So minus 4ac by 4a square. So minus c by a, so you can take it like this, minus c by a into 4a square. So a and square cancels. Minus c into 4a is minus 4ac plus b square by 4a square into 4a square is b square. Right. I am going fast?
No.
Okay. It's a matter of time, that's why. So now we will alter this. So x plus b by 2a whole square is equal to b square minus 4ac. I am altering this by 4a square. So let us take square root on both sides. Because I have a perfect square here, I will take square root on both sides. So square root of x plus b by 2a whole square is equal to square root of plus or minus, I am going to write the sign here, right? Plus or minus square root of b square minus 4ac by
4a square.
4a square. So square and root
Cancel.
cancel. So you are left with x plus
B
b by 2a is equal to plus or minus. We'll apply square root for b square minus 4ac and for square root of and 4a square separately. This can be done according to the law of indices. This can be done. Okay. So x plus b by 2a is equal to plus or minus square root of b square minus 4ac by square root of 4a square I have here. So 4 is a perfect square, a square is also a perfect square. So square root of 4a square is
2a.
2a. Okay. So I am going to send this plus b by 2a to transpose to LHS, that is RHS. So x is equal to minus b by 2a plus or minus square root of b square minus 4ac by 2a. You can take LCM here. You can take LCM. So x is equal to, when you take LCM here, it becomes 2a. Minus b by 2a into 2a is minus b plus or minus square root of b square minus 4ac. So this is the required formula to calculate the roots of any given quadratic equation. So x is equal to minus b plus or minus square root of b square minus 4ac by 2a. So when you split this, this becomes x is equal to minus b plus square root of b square minus 4ac by 2a. This is one of the root of this, and another root is x is equal to minus b minus square root of b square minus 4ac by 2a. This is another root. So when we solve any quadratic equation, we get two roots, right? So generally when we solve that is standard form of a quadratic equation, we get two roots. So those two roots, among them one is this, another is this, right? So when we solve any quadratic equation by using formula, so these things happens inside the formula there. So minus b plus square root of b square minus 4ac by 2a, and x is equal to minus b minus, that is only the difference, right? Minus square root of b square minus 4ac by 2a. So this will be the formula where we are going to use, and these are the two roots of the standard form of a quadratic equation. Alright. So in tomorrow's session we will be going with very important 2 marks problems on this particular formula method. Right. So please practice the problems, stay home, stay safe, and keep learning. Thank you.